So let x1, x2, xn be a random sample. From a continuous distribution. Okay. With PDF given by fx theta is equal to 2x by theta square, where x lies between 0 to theta and 0 otherwise. Okay. So we will look at this distribution and various kind of inferences we will try to do. Okay. So let me pose the problems here. Method of moments estimator and maximum likelihood estimator of theta. Okay. Find minimal sufficient statistics. Let me call it, we can give some name to it. So minimal sufficient statistics we can call, say, y. Okay. Then I have another question. Is y complete? Find the minimum variance unbiased estimator for theta. So let me give some names here for each of these estimators. So I will give some names here. This one, let us call it T1. This one I will call, say, T2, and UMVUE, let us call it T3. Okay. And then I will ask you to compare mean squared errors of T1, T2, T3. Okay. I hope the problem statement is clear. So please attempt this problem now and then tell me the solutions. Not very difficult, but you have to work it out. So let me ask you to switch on your video so that I can see who are all attempting the problems. Okay. Please switch on your videos, because I will give then attendance only to those who are present here, not to all. Reddy. Okay. So I think all others, they have just switched on. They are not present. So I will not give attendance for today's class to other students.
Sir, mu theta by 3, MME 3x 3 alpha by 3 alpha 1 by 2, MLE of theta xn.
Okay, what is the mean here?
2 theta by 3.
2 theta by 3, that is the mean. Okay. So mu1 prime, that is 2 by 3 theta. Yes. Okay. So what is the method of moments estimator here?
3 alpha 1 by 2.
3 by 2 x bar.
X bar.
Then maximum likelihood estimator?
Xn.
Okay. Then you have to find the minimal sufficient statistic.
That is also Xn.
That is also Xn. Okay. Now, then next question is it complete?
Yes, sir, complete status.
So this is complete. Why it is complete?
Like expectation of that g of that integral.
G of y.
Yes, that is.
So what is the distribution of y? Because you have to use the distribution of y to prove the completeness of y. So what is the distribution of y?
Two n into x power n minus 1 by theta square. Theta power 2. F is smaller.
The PDF of y, that is, you said 2n y to the power 2n minus 1 divided by theta to the power 2n.
2n.
So from here you can prove that it is complete. So that is expectation of g of y is equal to 0 for all theta. So this is equivalent to the condition that integral g of y 2n by theta to the power 2n y to the power 2n minus 1 dy, that is equal to 0 for all theta positive. So these are all constant terms. Now you are saying integral of certain function of y on all the intervals 0 to theta is 0. So this implies that gy itself must be 0. Okay. And if that is so, then you can say that the probability of gy is equal to 0 is 1. So therefore y is complete. If y is complete, then what is the next question that I have asked? Find out the UMVUE T3 for theta. What is the UMVUE? Because once you have a complete and sufficient statistics, then you should be able to derive the UMVUE by looking at the expectation of a function of the complete sufficient statistics, which is equal to theta. So once you do that, you will be getting the UMVUE. So since the distribution of complete sufficient statistic is known, you can immediately try to find out that. Okay, so find out what is the UMVUE now based on y, which I am calling T3.
Two n plus 1 by 2n into y.
What did you say?
2n plus 1 by 2n into y.
So you have to calculate the expectation of y, which you can obtain from the distribution here, that is 2n by 2n plus 1 theta. So it means that if I consider 2n plus 1 by 2n y, that is T3, then this becomes UMVUE of theta. Okay. So now at our disposal, what are the things that we are having? We are having the method of moments estimators, that is T1, that is 3 by 2 x bar. We have the maximum likelihood estimator, we are calling it T2, that is xn. And we are having the uniformly minimum variance unbiased estimator, which I am calling T3, that is 2n plus 1, 2n plus 1 by 2n xn. Y is actually xn. So that is UMVUE. So the next part I have asked, because once we have several estimators, then we would like to compare them. So what is the comparison of these estimators? The method of comparison is to look at the mean squared errors. So calculate the mean squared errors of the estimators, that is mean squared error of T1, that is expectation of T1 minus theta square, and so on. MSE of T2 and MSE of T3. We have to compare them and find out which estimator is the best among these three estimators. Okay, so please do that now. Calculate the mean squared errors of T1, T2 and T3. Okay, so please write down the mean squared errors of T1, T2, and T3. In the case of T1 and T3, mean squared error is the same as the variance of the estimator. Okay, because they are unbiased. Only for T2 you have to calculate separately. That is the mean squared error. Okay, so I think at least variance of T1 have you calculated by now?
So MSE of T3 is n theta by n plus 1 into 2n plus 1 whole square.
Okay, let me just write it here. MSE of T3, that is basically variance of T3. Okay, so what did you say it is equal to?
N theta by n plus 1 into 2n plus 1 whole square.
N theta by
Theta square, n theta square.
n theta square by
N plus 1 into 2n plus 1 whole square.
2n plus 1 square.
Yes.
Okay. And what about the mean squared error of T1? That is because it is also unbiased, so it is variance of T1.
9 theta square by 8n.
Are you sure? Or is it theta square by 8n? Check it.
Yes, sir. Theta square by 8n.
I think some other student should also cross check it. I mean, only one student is telling. So others should also tell. Shreya, are you able to do the calculations?
Sir, I am doing right now.
I mean, are you able to cross check any of these statements which one student is telling?
Sir, I was calculating for T3, but my answer is different, so I am rechecking it.
Okay. And T2 also you have to find out. Okay.
Sir, that T3 was one for T2. I forgot to mention.
So T2 also you check properly. I think you are not getting correctly. T2, it is so that is expectation of y minus theta square. Okay. So it is theta square by n plus 1 into 2n plus 1. So can anybody check it? The expression which you are told is not accurate. There is some difference here coming. Yes, please. I would like to hear from you actually, rather than myself writing all the expressions.
Is it theta square by 2n plus 2 T3 one?
Theta square by
2n plus 2.
2n plus 2. I doubt it. It
Okay.
won't be a single term.
Okay, let
Yeah, anybody else has got?
Sir, is it theta square by 4n n plus 1?
That is correct. Did you say this?
Yes, sir.
Yeah, that is okay. And MSE of theta 2, T2, is the second expression true or the first expression?
Sir, I got second expression.
This one.
Yes, sir.
Yeah, so I will remove this one. So now we have at our disposal all these expressions. Mean squared error of T1 is theta square by 8n. Mean squared error of T2 is theta square by n plus 1 into 2n plus 1. And mean squared error of T3 is theta square by 4n into n plus 1. So we need to compare these, okay? Because the one which has the smallest will be considered to be the best. All of them are simply multiples of theta square. So whatever statement you write, it will be valid for all theta because same multiple is coming there. So you will not have difficulty in that comparison. So only the denominators need to be compared. Okay. So for example, you compare this. So I compare 4n into n plus 1 minus n plus 1 into 2n plus 1. Okay. Suppose I am comparing T3 and T2. Okay. So this is equal to 4n square plus 4n minus 2n square plus 3n plus 1. So that is equal to n minus 1, which is positive because n has to be greater than or equal to 1, isn't it? So basically you can say like this. So basically what you are getting that for n is equal to 1, see for n is equal to 1, what will be this term? This is theta square by for n is equal to 2 into 5. So that is theta square by 10. and for n is equal to 1, this will become theta square by 8. Yeah, theta square by 8, and this will be theta square by 10. What did I get?
So the second one by theta square by 6, right?
Yes, sir.
Oh, sorry. N is equal to 1, yeah. So mean squared error of T3 is smaller than the mean squared error of, because the denominator term of T3 is larger than the denominator term of T2, isn't it? So therefore, mean squared error of T3 is less than or equal to mean squared error of T2. Okay, what about comparison with T1? T1 you have 1 by 8n, theta square by 8n. So you compare again. For example, if I want to compare with T3, okay, so this is 4n square plus 4n minus 8. So in general, this is going to be like, if I take n is equal to 1 itself, this is 8, and then therefore this is greater than or equal to 0, isn't it? So T3 is better than both T1 and T2. What about comparison between T1 and T2? If I look at, so in T2
is
we
better
have,
than
T2 is better.
yeah, that is 2n square plus 3n plus 2, that is 2n square plus 3n plus 2 minus 8n. So sorry, I forgot here, this is 8n here. So 2n square minus 5n plus 2. So again it is greater than or equal to 0 here. Of course, except at n is equal to 1 here. So we can put for n greater than or equal to 2 here. Okay. So T2 is better than T1. So look at the statistical inference problem here. If I am considering estimation of the parameter theta here in this problem, of course, why parameter theta? Because the mean here is 3 by 2 theta. So it is just, 2 by 3 theta. So it's just a multiple of the mean. So like estimation of the mean is one of the important problems in statistical inference. So what you are getting here, you are able to calculate the method of moments estimator, the maximum likelihood estimator, and the UMVUE. In this particular problem, UMVUE is turning out to have the best performance. Okay, now practically speaking, what does it mean? Okay, so practically speaking, it means that given the data x1, x2, xn, mean squared error is smaller, means that it is taking care of the dispersion in the estimator better, isn't it? Because when you have different sampling, different type, the sampling is done, so there is a variation in the sample. Now the UMVUE has the smallest mean squared error there, therefore this will actually lead to the best decision making, especially for the small samples. If the sample size is large, suppose I consider n very large. So if you compare T2 and T3 here, so what we have written here, T2 and T3, T2 is xn and T3 is 2n plus 1 by 2n. So as n becomes very large, that's 2n plus 1 by 2n plus 1 by 2n, it will go to 1. So the UMVUE and the maximum likelihood estimator, they will become almost the same. But for small samples, it will matter, because for small samples, suppose I say n is equal to 5. So for n is equal to 5, this will become 11 by 10 y, and that is y. So they are different. Suppose I take n is equal to 4, then it is 9 by 8. So which is different from y. So for small samples, the distinction is important here. But definitely in all the cases, these are better than the method of moments estimator. In the beginning, I gave you a little bit of history there. I mentioned to you that the method of moments is something like primal kind of thing. In the very beginning, Carl Pearson has given around 1900 basically as a first method of estimation. Okay, but later on, R.A. Fisher has given the method of maximum likelihood estimator, where he said that actually you should maximize the likelihood. That means you should choose that thing as an estimator which maximizes the likelihood function. So in that sense, it is a significant, you can say, procedure from a practical point of view, because it is maximizing the probability. Likelihood function is nothing but the probability density or the probability mass function. So that is what it is coming here. In this particular case, you are actually able to show that the MLE is having a smaller mean squared error as compared to the method of moments estimator. But of course, now we have more techniques available. So we are actually able to derive the UMVUE here, and we are able to show that it is performing even better than the maximum likelihood estimator in this problem. It is not true statement in general, but in this particular problem, it is performing better. Okay. So is this discussion clear? Actually, I took a real example here. Okay, what kind of distribution this is? If you plot it, how it will look like? That x equal to 0, it is 0, and at x equal to say theta, this will become 2 by theta, isn't it? So it is something like a triangle distribution kind of thing. Okay, some sort of triangle. Okay, it's a triangle distribution. This is the thing. So when you have data of this nature, then the inference procedure is that UMVUE performs better. Actually, after the midsem, I will talk about another concept, that is invariance, and we will see that even the UMVUE may be surpassed. That means we may have something better than UMVUE also, but I will talk about that later on. Right now we have discussed this. So if this is clear to all of you, then I will move to the next problem. Is it okay? All of you are able to understand?
Yes, sir.
Let me just ask one of
Yes,
the students here. Yeah, Shreya, did you follow it?
Yes, sir.
Okay. Priyanshi, did you follow the example?
Yes.
Okay. Yeah. So let me now go to another exercise. So basically, in inference problem, you need to be familiar with the calculations of the probability, moments, okay, moment generating function and other things, because these are the things which will be used in, and also you have calculated the probability distribution of the sufficient statistics, etc. Okay, so these are the some of the basic things that you need to do. Suppose I have an observation x from a continuous distribution with probability density function. It is given like this: fx theta is given by half 1 plus theta x for x lying between -1 to 1, and it is 0 elsewhere. Okay. So we will do various things here. Okay. Find expectation x and say expectation of x square, and of course variance of x. Okay. Find expectation of mod x. Okay. Variance of mod x. What is the minimal sufficient statistics? Is it complete? Okay, so let me stop at this point and firstly you solve this and then I will ask you some other part of it. So I have not taken a random sample. I have taken only one observation. Okay. So the inference will be based on X only. Okay, so are you able to get some of the questions here? What is the mean?
So theta by 3.
Okay, so expectation of X is equal to theta by 3. What is expectation of X square?
1 by 3.
1 by 3.
Okay, so of course variance will come from here. That
3
is
minus theta square by 9.
what did you say?
3 minus theta square by 9.
Yeah, 3 minus theta square by 9. Okay, then I ask some more related questions. What is expectation of mod X?
1 by 2.
1 by 2.
Okay, and what is variance of mod X?
1
1
by
by
12.
12.
Now, what did you say?
1 by 12, sir.
1 by 12. Okay. So this is just some basic calculations. These are required for further part. So now we come to some questions here. What is the minimal sufficient statistics here? So you have to apply the definition here. That is, you have to write fx theta by fy theta, and what is the necessary and sufficient condition for it to be free from theta. So because I have defined the minimal sufficient partition by the equivalence relation. Equivalence relation is that if x is related to y, if and only if fx theta by fy theta is independent of theta or free from theta. Okay. So writing down that definition, if and only if condition you should be able to get. Okay.
Sir, it will be independent only if all xi are 0.
Now, what is all xi's? There is only one observation.
Okay, sir. Then that observation should be
Why? Why that observation should be 0? But observation being 0 does not give any relation. See, I want to get a partition, no? Minimal sufficient partition. So that does not give. Why should it be 0 as a necessary and sufficient condition? It may be a sufficient condition, but not necessary. Yes, anybody else? Gaurav?
No, sir, I don't know.
Yeah, anybody else would like to answer? Or you would like to revise your thinking? Priyanshi? I can't hear you. Can you speak loudly?
Sir, I'm thinking about it.
Okay. Shreya?
Sir, I am not getting it.
So what I said, you write fx theta by fy theta. When is it independent of theta? You have to get a necessary and sufficient condition for that.
Okay.
So somebody said x should be 0, but that doesn't give any relation, x equal to 0. So in the domain of the definition, it is equal to 1 plus theta x by 1 plus theta y, isn't it? Where I am taking the domain of definition minus 1 less than x less than 1, minus 1 less than y less than 1. Because in other places there is an issue, so I won't write that. So this is free from theta if and only if x is equal to y, isn't it? So x is minimal sufficient. Now the next question is x complete? That is the next question. The minimal sufficient statistics, is it complete? Because that is always, if you get a complete sufficient statistics, then the problem of UMBU becomes easy. Yes. So you just check whether it is complete. Shashank, is X complete?
Sir, I'm trying to find.
Excuse me, sir.
Yeah,
Sir, I think that it is complete.
it is complete. So what is the proof?
So because if we take any gx and we integrate within the limits, function, the probability of gx is equal to 0 is 1.
You are getting integral -1 to 1 gx into 1 plus theta x dx is equal to 0, isn't it? That is what you are saying. It is true for all theta. Then this should imply that gx is equal to 0.
Yes, sir.
So why should it imply that gx is equal to 0?
So because for all x, the integral is coming out to be 0.
No, not for all x, because integral is with respect to x. So it is equal to 0. That is integral of -1 to 1 gx 1 plus theta x dx is equal to 0 for all theta.
Okay.
So basically you are saying theta is equal to, in fact you can simplify, you can put integral -1 to 1 gx on the other side. So theta is equal to minus of integral -1 to 1 gx dx divided by integral of x gx from -1 to 1 dx. Okay, that is what you will get as theta for all theta. So why should g be 0? I mean, in what way? I have given you earlier the arguments that integral over all the intervals is 0, therefore the integrand must be 0. Or we got Laplace transform is 0, therefore the function should be 0. Or the power series or the polynomial that becomes identical over an identically 0 over an interval, then all the coefficients must vanish. So these are some of the arguments that we have used for the completeness proofs. Why here it should imply? What is that? There is no transformation here. It's just a linear term.
Yes, sir. I was thinking about all x. Sorry.
Yeah. Anybody else? Shreya?
No, sir, I was also thinking the same way as Priyanshi, but no.
Gaurav?
No, sir.
I asked you to do some calculations. No, the first part of the exercise was calculating some terms, expectation x square, expectation mod x, and so on. So why did I ask you? Now looking at those calculations which you have done, can you answer this question about completeness? You calculated, no, expectation x square, expectation mod x, and so on. So does it help you to answer this question? If I choose, say, gx to be x square minus 1 by 3, then expectation of gx is equal to 0, isn't it? Because expectation of x square, but gx is not 0 because x square is not necessarily equal to 1 by 3. X lies between -1 to 1. But probability of gx is equal to 0 is not 1. So x is not complete. You can argue from here also. I can take, say, hx is equal to mod x minus 1 by 2. So if I take expectation of hx, then that is also 0, but hx is not 0 with probability 1. So x is not complete. Answer is no. So although I have got here expectation of x is equal to theta by 3, so I will get unbiased estimator of theta based on x. Okay. You will get expectation of 3x is equal to theta. So let us call it t as equal to 3x. So t is unbiased. But I cannot say that it is UMVUE. Okay, because if t is now, x is actually minimal sufficient, but it is not complete. So Rao-Blackwell-Lehmann-Shafi theorem cannot be applied here. Okay. Anyway, so I will give you some further exercise. Let us define another estimator. I will call it TC. TC is equal to 3x plus c times mod of x. Okay. So do some exercise now. Find expectation of TC so that TC is unbiased. For theta. Okay. So what would be your answer?
Sir, what does that mean? Find expectation of TC such that TC is unbiased.
That means expectation TC must be equal to theta.
Then shouldn't the C be 0?
Yeah, so you should tell that. That's what I was asking. Yeah. So then T0, and that means T0 is unbiased. Okay. Because I wrote an estimator, no? I wrote T here. Now I am changing T by modifying little bit by adding some more term here. Okay. So since this will add something, because expectation of mod x you have shown to be half. Okay. So therefore, it will be unbiased only if C is equal to 0. Now this is some trick here. Actually, in the statistical inference, these are certain things. So because I was not able to show that 3x is minimum variance unbiased estimator, because completeness was not there, and I did not try that Rao-Blackwell, that Rao-Kramer lower bound and so on. So I'm just exploring a little bit. So just look at how the statistician's mind works here. Now I'll ask you some further thing. Find variance of TC. Okay. So this is some exercise. You have to do it now. It cannot be done in 1 minute. You just please solve it, because this is involving 2 terms here. So many things will come. So find it out. Since I asked you to do some calculations, those calculations will be used here, because this is nothing but variance of T0 or T plus C square variance of mod x plus 2 times C covariance between T and mod x, where T is 3x. Okay, I already defined that. T is 3x, that is T0. Okay. So please substitute all this and tell me the steps here. Because you have already calculated variance of x, you have also calculated variance of x mod x, and this one will require little bit further calculation, because covariance between 2 random variables x and y, it is expectation of product minus product of the expectations. Okay. So since T is equal to 3x, covariance is nothing but expectation of 3x into mod x minus expectation of 3x into expectation of mod x. All those terms you have already calculated. Only one term you need to calculate afresh, that is expectation of x into mod x. So that is what you have to just substitute and tell me this. Okay. Variance of x you have calculated 3 minus theta square by 9, isn't it? So variance of t, that is 9 times variance of x, so it is simply 3 minus theta square. And variance of mod x you have written. What was variance of mod x?
1 by 12.
1 by 12. So that is c square by 12. So this is the term that you have to write, that is expectation of x into mod x minus again this is expectation of t into expectation of mod x. So these terms also you have already written. So only one extra term you have to calculate. So calculate it and tell me this. That is 3 minus theta square plus c square by 12 plus, just tell me what final thing is coming here.
Two c into 1 plus theta by 4.
Just see it, check it again. 2c. Yeah, so after simplification, what term you will get? 2c into this term, what you will get?
1 plus theta by 4.
Now see it carefully. I think you are making some mistake here. Just check it again.
Sir, expectation of x mod x is theta by 4.
Theta by 4, correct. That is theta by 4. So this is becoming 3 theta by 4. Okay. And expectation of t is theta and expectation of mod x is half. So 3 theta by 4 minus theta by 2. So that becomes theta by 4. Okay. So you get finally 2c into theta by 4, that is c theta by 2. Is that okay? That is what you said? Do you agree with this calculation? So this is basically some integration exercise. So I will now do some little bit of things here. Suppose for a given theta, for a fixed theta, say theta is equal to theta naught, find c such that variance of Tc is minimum. So this is some calculus, you can do it immediately because this is c square plus something is coming, so immediately you can tell me the answer. What is the value of c for which
minus 6
variance?
theta naught.
What did you say? What did you say? Repeat it.
Minus 3 theta naught.
Minus 3 theta naught. So if I am considering the estimator this, okay, this has so this is just some exploration, okay, some exploratory exercise. at a particular point, I am able to get another estimator which is having a smaller variance than that estimator. So this is just an exploratory exercise. This is not a full solution. Actually, there is another theory which is developed little bit more, but at your stage, I will not be able to complete those arguments here. If we have a function which is convex and we are having minimum and maximum values in certain range, like functions are of this nature. Okay, and then I get maximum and minimum and the maximum values of the minimizing choices. Then this class is sort of desirable class of estimators actually. But anyway, I think this part I will not do at this moment. I mean, those who are desirous of doing advanced things, you can discuss later. Okay. Let me move to something which we have already discussed enough, but even then I will give you some additional work there. So I consider x1, x2, xn is from normal distribution with mean mu and variance sigma square. This problem we have explored enough. Okay, so I will not ask you the routine things. X bar s square. This is complete and sufficient. Okay. X bar is UMVUE of mu. S square is UMVUE of sigma square. We have also done like x bar is method of moments estimator of mu, and if I consider n minus 1 s square by n, which I give another notation, I can call it s star square. This is MLE, MME of sigma square, and these are also MLE. Okay, both are MLE. In the context of normal distribution, I have also explained another related problem, that is the estimation of the quantiles, that is mu plus alpha sigma kind of terms. Okay, because 3 sigma limits are important, so we have mu minus sigma, mu plus sigma, mu minus 2 sigma, mu plus 3 sigma, etc. These are important points. So I have given you in general the estimation of mu plus alpha sigma. Okay. Another important parameter which is there in the context of normal distribution, it is fourth moment. Fourth central moment, if you remember, that is 3 sigma to the power 4. Okay, because it is used for the measure of kurtosis. So if we calculate the measure of kurtosis in the normal distribution, it is 3 sigma to the power 4 by 4 by sigma to the power 4 minus 3, that becomes 0. So suppose we are estimating raw value of the kurtosis, okay, rather than the normalized value. So I will need the estimation of sigma to the power 4. So I am asking you now, find UMVUE of sigma to the power 4. Okay, so in general I can pose the problem. You can consider estimate sigma to the power p. Okay, so rather than just sigma to the power 4, because then if you put p equal to 4, you will get the general. So you please solve this problem. I have already given you the essential ingredients here. That is the complete sufficient statistics, basic UMVUEs, MLEs, etc. are given here. So find out the UMVUE of sigma to the power p, and as a consequence find for sigma to the power 4. Okay, so please solve this problem and tell me the solution. The necessary distribution theory is available to you. X bar follows normal distribution with mean and variance given by mu and sigma square by n. The distribution of n minus 1 s square by sigma square is chi square on n minus 1 degrees of freedom. So these are certain things which are already known to you. Okay, if you are finding the general problem more difficult, then find for sigma to the power 4 first. Okay, for sigma to the power 4, are you able to get it? Are you able to get it for sigma to the power 4?
Two into n minus 1 plus n minus 1 whole square.
Say it again.
Like expectation of chi-square distribution expectation of like,
No. So what is the UMB for sigma to the power 4? What did you say as the UMB
n minus 1 whole square into s power 4 by 2n minus 2 plus n minus 1 whole square.
2n plus 2. How did you get that? No, some mistake you are telling. Can you tell your steps of your calculation? Some mistake you are making.
Expectation of n minus 1 s square by sigma chi-square distribution whole square. Expectation is.
Now what is that? What is that expectation square? See, if I write here n minus 1 s square by sigma square, that is following chi-square distribution on n minus 1 degrees of freedom. Okay. So since I am asking for sigma to the power 4, I should consider expectation of w square. What is expectation of w square? In the chi-square distribution, what is the second moment?
2 into n minus 1 plus n minus 1 whole square.
It is simply n minus 1 into n plus 1 here. Because the second moment, if I take nu degrees of freedom, that is nu square plus 2 nu. Isn't it? That is the second moment. Here nu is n minus 1. So this is n minus 1 square plus twice n minus 1. So that is nothing but n minus 1 into n plus 1, which you can write as n square minus 1. So from here, if you write the statement n minus 1 square s to the power 4 by sigma to the power 4, that is equal to n square minus 1. So this gives you expectation of n minus 1 by n plus 1 s to the power 4 equal to sigma to the power 4. So because of the complete sufficiency is already there, so n minus 1 by n plus 1 s to the power 4, this is UMVUE of sigma to the power 4. So now I have asked you another question for sigma to the power p. Okay, so you now tell me from there. Of course, you will have to calculate little bit. It is not one step, you have to actually write the expectation there. So what is the UMVUE for sigma to the power p now? That you have to calculate. So please work it out. Now, is it not clear that what you have to do? Hardik?
Sir, I'm trying.
Naidu?
Yes, sir, I'm trying. So some large expression.
So what are you considering?
Expectation of n minus 1 s square by sigma square whole power p by 2.
Yeah, right.
That is integral of the chi-square distribution.
So you consider expectation of w to the power p by 2 because w is having square there, s square by sigma square. So if you consider expectation of w to the power p by 2, so that should give you a term which will involve sigma to the power p. That will be enough. So w to the power p by 2, and you write down the density function of chi square on n minus 1 degrees of freedom. So that is equal to 1 by 2 to the power n minus 1 by 2 gamma n minus 1 by 2 integral 0 to infinity e to the power minus w by 2 w to the power n plus p minus 1 by 2 minus 1 dw. So this is nothing but the gamma function. So the value will come straight forward. That is gamma n plus p minus 1 by 2 divided by half to the power. So that will go in the numerator. I'll write here 2 to the power n plus p minus 1 by 2. So that is equal to twice 2 to the power p by 2 gamma n plus p minus 1 by 2 divided by gamma n minus 1 by 2. So that will give you the solution now, because expectation of n minus 1 s to the power p, this is p by 2 by sigma to the power p, that is equal to this term, that is 2 to the power p by 2 gamma n plus p minus 1 by 2 divided by gamma n minus 1 by 2. So you take these terms to the left hand side and you will get expectation of n minus 1 by 2 to the power p by 2 and this gamma n minus 1 by 2 divided by gamma n plus p minus 1 by 2 s to the power p, that is equal to sigma to the power p. So this is your UMBUE for sigma to the power p. So in estimation problems, you have to do some work actually. Just by thinking, you will not get any solution. So whatever you need to do, you have to actually work it out. Okay.